All right, thanks. So this talk will be a little bit change of pace. So we'll talk about using energy storage in data centers and how that can help us integrate sources like wind and solar. Okay? So a little bit of background. If you look at electrical grids, the grid is actually changing quite a bit. Right? So one change on the supply side is that we have renewables coming in, right? Wind, solar, things like this. And the big challenge is that these are random resources. They're really hard to forecast, and we can't dispatch them. So on the demand side, if you look at the other side, on the demand side, one of the fastest growing demand is actually data centers. As we move more and more stuff to cloud computing, they eventually end up here. So if you look at all the components of the grid, this is growing by far the fastest. And the challenge is it's getting quite expensive to operate these data centers. Right? So it's not small money to operate a huge data center. And the point of this talk is they can help each other. Okay? So data centers can use renewables to be less costly, and we can help to sort of average out the randomness in renewables. Okay? So if we look at the cost in a data center, you can basically break it into several parts. And these numbers are from an actual data center from Microsoft, a 10 megawatt data center. So a bit of context, 10 megawatt is about 10,000 households. And this is a fairly small data center, actually. Okay? So if you look at all the pieces of the pie, this is the actual infrastructure, how much it takes to build a data center. These are the computing servers, and we're going to focus on the utility bills. This is the bill the data center pays monthly to the grid. Okay? And in fact, we're getting better and better at building servers. So the cost of server is actually going down, but the cost of electricity is not. Right? So in the 2011, we spent about $7.4 billion, and this is projected to double in 2020. Okay? So the cost, actually, electricity bill starts to dominate. And so of course, there's a lot of effort trying to reduce this bill, the monthly electricity bill. So if you look at data center, if you're not familiar with how a data center is set up, it's basically a bunch of servers here, and a bunch of other systems here, right, to deliver power and cooling to these servers. So there's two ways to reduce the cost of a data center. One is to increase efficiency. That is, for the power I send into this entire data center, I want most of them to end up powering the servers. It turns out, actually, this efficiency was not that high if you look at, say, data centers 10 years ago. In fact, 10 years ago, about half the energy we put into data centers is used for cooling and other things and lost in the system. Okay? But through the last decade, we made a lot of progress increasing data center efficiency. And nowadays, for commercial data centers, you're actually 95% efficient, more than 95% efficient. Okay? So most of the power goes into the data center, goes to flip the bits. Right? So there's not much I can squeeze out here. It's already pretty efficient. So in this focus of this talk is I'm going to use storage in the data center to shift energy around in time. And this can actually help quite a bit. Okay? So if all data center has storage, and it's a part of the power supply. Okay? So storage basically normally used as a failover mechanism to diesel generators. So if the power cuts out for some reason, the data center will operate on the batteries, then it'll switch to its on-location generator. And this storage has a particular feature. That is, it's very high power and so low energy. So it's able to pick up all the load in the data center for a few minutes. Right? So the power is very high, energy is not so much. And it's actually very rarely used. So nowadays, the grid is very reliable. And unplanned outages is very rare. So if you look at it on average, storage in data centers, most of them are used less than a minute a year. And so we never use them. They just sit there and leak energy and have to throw the storage out every 4 or 5 years and buy new batteries. And this is a very inefficient usage of this. Okay, so why not use them in normal operations, right? And turns out, so high-level result is actually this storage are very useful. They can reduce bills. I will show some simulation later, by up to 20% and help us to integrate renewables. Right? There's actually quite a bit of savings you can get by using this storage. Right, so let's take a look at how data center pays its bills. So there's actually two parts to the bill. The first part is energy cost. And this is, we're all familiar with this cost. This is dollar per megawatt hour. This is proportional to the total amount of energy used, let's say in a month. The second part is actually called peak demand charge. And this has a unit of dollar per megawatt. So this is the maximum demand you draw in a certain period. So let's say you operate in a month. Utility will look at the maximum power and charge you some money on that. Okay? So for large industrial customers, this can be very significant. In fact, for data centers, each part is contribute roughly equal to the total cost. Right? So the bang of buck really comes from reducing this. Right? If I can reduce peak by a little bit, it's really worth it. So using storage to do peak shaving is sort of very intuitive. So this is an example trace of data center power consumption. And I can use storage basically to flatten this trace out. Right? I just reduce the peak, I fill up the valley, and I get a lot of saving. Okay? I got a lot of saving, and this tells us sort of when you use energy is important. Right? It's not just to shift this whole curve down. Right? You want to strategically shift the peak downwards. Okay? So this is one thing we can use battery for is peak shaving. So let's go back to renewables. What does renewable have to do with any of this? Well, if you look at the grid must maintain the balance between supply and demand, right, at all time scales. And this is becoming harder and harder as renewables enter the system because renewables are uncertain. So I need a lot more renewables. So basically, here we're going to focus on regulation service, which is a second-to-second balancing in the system. Essentially, what the system gives you is this sort of random signal that's saying, right now, what is the imbalance in the system? And you try to follow the signal. Okay? And this turns out to be ideal for a high-power, low-energy battery because this is very fast changing. So as long as I can output a lot of power, then I can make a lot of money by balancing these. Right? So if you look at the total bill, we have three parts. I have energy cost, I have peak power demand, and I have market revenue. Right? So I want to basically minimize this bill. Right? So if I have a battery, I now have three objectives for this battery. I need to do peak shaving. I need to provide regulation service. And of course, I'm battering the data center. I need to provide some backup. There are so multiple things the battery has to do. And the optimization problem is like this. And the computational challenge is that this is fundamentally an online program. I don't know what the regulation signal is. That's essentially random. I don't know what my data center load is. That's also somewhat random. And I need to operate this battery in an online fashion. Okay? So battery needs to serve multiple objectives. And definitely, we're not the first ones to think of use battery like this. So both people have thought about using batteries for peak shaving and regulation service before. And it turns out for individual services, the result is very mixed. It's not clear if battery can actually save you money if you do individual services. So in this talk is actually saving from joint optimization. If you do both at the same time, is actually larger than the sum of individual applications. Right? So doing both is actually the whole is greater than the sum of the parts. And the main thing is take care of diversity. So there are stochastic processes, but at one time, one of the applications is good to me. Right? So I can take advantage of diversity. Okay, so I'm going to skip this. Basically, we have a simple control algorithm. Let me just show you the examples. So this is the actual Microsoft data center trace. This is the regulation service market. So this is the bill if you don't do anything. If you do peak shaving, you get a little bit reduction. If you do regulation service, you get a little bit reduction. If you do both, you actually get a huge reduction there. Right? So this reduction is more than the sum of these two. Right? So we have some sort of superlinear saving. It's really saying if you have multiple objectives, it's actually beneficial to you. That means there's diversity in the system. You should explore the diversity in the system. Okay? And this is again some result is saying that on average, if you run the simulation for half a year, joint optimization give you around 20% savings, where each individual, which if you just do one of them, the maximum you can get is about 10%. Okay, so to conclude, again, you should use batteries in data centers or use batteries in other things, right? They're mostly now they're just sitting there without doing anything. And they both reduce costs and integrate renewables. And some future work is right now we have a pretty simple battery degradation model. And in fact, when you use battery, it reduces the life of the battery. And the chemistry here can be quite complex. So we need to have a better model here, and then that leads to better online control strategies. That's it.
Well, the last speaker sets up. We can take one question.
So I know in talking with other people, they say that often you want to use a different battery design if you're doing, say, regulation than if you're doing emergency backup.
Right.
So would it make, I mean, is that true in this case?
No, in this case, turns out the battery is well designed for both of them. So basically, you really want backup for a very short time. So it's very high peak energy. And you can serve a lot of regulation using that battery.
I've been also working in joint optimization. We find that the revenue frequency regulation tends to dominate. I'm very curious. Do you have this written up? That's a technical article?
Yes, I can share with you that.
Great.
Thank you very much.